So we have two more problems. They're motion problems. Susie takes 50 minutes to hike uphill from the parking lot to the lookout tower. It takes her 30 minutes to hike back down to the parking lot. Her speed going downhill is 1.2 miles per hour faster than her speed going uphill. Find Susie's uphill and downhill speeds. Okay, so here's the hill, and Susie's gonna, this is Susie, she's gonna climb up to the tower, and then she's gonna climb back down, okay? So she's going up, and then she's gonna go down. So we're gonna set our chart up, and remember we talked about there's always two things going on, two different things. So she's gonna go up the hill, and then she's gonna come down the hill. And then we've got a rate, a time, and a distance. Rate, time, distance. Now, an interesting thing on this problem, it says Susie takes 50 minutes. That's minutes, that's not hours. So we need to convert that minutes to hours because our rate is in miles per hour. So 50 minutes would be 50 out of 60 minutes, or 5/6 of an hour. So when she's going uphill, it's taking her 5/6 of an hour. Now that's a really easy thing to miss. So you want to be careful with the units. They're talking minutes and we're talking hours on the rate. So we've got to match those up. So we're going with a 5/6, a fraction of an hour. Okay? It takes her 30 minutes. That's a little bit easier to do. So 30 minutes to hike back down, or half an hour, right? Half an hour is 30 minutes. So it takes her a half hour to go back down. She's faster going down because it's downhill. Okay. Her speed going downhill is 1.2 miles per hour faster. So if I make her speed going uphill x, then her rate going downhill is going to be x plus 1.2. Now I've got decimals and I've got fractions, and goodness sakes. Okay. Find Susie's uphill and downhill speeds. Okay, the distance then she goes uphill is 5/6 times x. The distance that she goes downhill is 1/2 times x plus 1.2. I could make that a fraction. I could make it 12/10 and then reduce that. Okay, well, let's do that. So 1.2 is equal to 12/10, which is equal to 6/5. So that might be a little bit easier to work with. Keep them all fractions. You were thinking, let's go with the decimals, but I think we'll run into trouble with that 6. We'll get a repeating decimal. Okay, so 1.2 is the same as 6/5. I'll put that in at the next part. Okay, so how far she goes up to the tower, that distance going up has to equal how far it is to come back down. The distance is the same. Okay, so that's our equation. 5/6x equals 1/2 x plus 6/5. Let's go ahead and distribute that 1/2. Let's see what happens. There's more than one way to do this problem, but 1/2 x plus 2 would go, I'd have 1/2 times, I'll write this out, 6/5. So 2 goes into 6 3 times. So now I have 5/6x equals 1/2 x plus 3/5. Okay, so we're getting somewhere. It's starting to look a little better. Now, what would the LCD be for 6, 2, and 5? I kind of want to think about this, don't I? I'll go over here. So 6 is 2 times 3, and 2 is prime, and 5 is prime. So I'm going to need a 2, a 3, and a 5. So what's that, 30? Okay. 30 then is LCD. I'm going to go ahead and clear my fractions. So I didn't want them anyway. So I'm going to multiply by 30 on this side, and I'm going to multiply by 30 on this side. So I'm going to have 6 goes into 35 times 5x. Put a little 5 there. And then over here I'll have to distribute. So it's going to be 30 times 1/2 x plus 30 times 3/5. Oh, going to really run out of room. Okay, so I get 25x here. We're almost done. And then 2 goes into 30 15 times, so that's 15x plus, and then I'm going to have 5 goes into 36 times, and 6 times 3 is 18. Okay, almost done. So if I subtract the 15x, because I have to get x on the same side, I'm going to get 10x equals 18. So if I divide by 10, I'm going to get x equals 1.8. I went back to the decimal. Okay, so 1.8, what does that mean? It means that going uphill, her rate was 1.8 miles per hour. And I'm okay with that decimal because that's how they gave me the miles per hour when they were talking about going downhill 1.2 miles an hour faster. So downhill, her rate, just like we were saying, is going to be 1.2 plus the 1.8, which is going to be 3, or I'm going to put 3.0 so they know I didn't round off, but 3 miles per hour. So you could show that 1.8. This comes from 1.8 plus the 1.2 because she's going 1.2 miles an hour faster when she goes down the hill. These are tricky problems. That was a tricky one. Okay, save the best for last. All right, so now we've got one more. Hamilton loves to travel to Las Vegas, 255 miles from his home in Orange County. On his last trip, he left his house at 2 p.m. Okay, the first part of his trip was on congested city freeways. At 4 p.m., the traffic cleared and he was able to drive through the desert at a speed 1.75 times faster than when he drove in the congested area. He arrived in Las Vegas at 6:30. How fast was he driving during each part of his trip? So there are two things going on here. He's got congested traffic, and he's got clear traffic. And then we've got the rate, time, and distance. It's really nice, the book gives you so many examples. Okay, so let's see. The first part of his trip, that was the congested. And then at 4 o'clock, he started at 2, so for 2 hours he was in congested traffic. Sounds like going to Vegas. And then the traffic cleared, and he gets to Vegas at 6:30, so for 2.5 hours, decimal, I'll go with a decimal, 2.5 hours, he had clear traffic, so that's nice. All right, now let's talk about the speed that he's going. We don't know how fast he's going in the congested area, but we know that when it clears, and he was cleared and he was able to drive 1.75 times faster. So that's going to be 1.75 times x, okay? So the distance that he traveled in congested traffic was 2x, 2 times x. And then what is it for the clear traffic? Well, it's going to be 2.5 times 1.75x, whatever that is. Okay. Now, what do we know about where he went? He went a total of 255 miles. So how far he traveled in the first 2 hours, plus how far he traveled in the last 2 hours. That's got to equal 255. Okay. All right, so what I really want to know is what's 2.5 times 1.75? I got 4.375. Okay. Check it on your calculator, make sure I'm doing it right. Okay, now can I add 2 and 4.375? Yeah, so it's going to be 6.375x equals 255. Okay, let's divide by 6.375. So the steps, even though the numbers are a little weird, Steps are the same. Okay. So 255 divided by 6.375. 40. So x is 40. What does that mean? It means in congested traffic he was only going 40 miles an hour. So the question says, how fast was he driving during each part of his trip? Well, in traffic, his rate was 40 miles an hour. Clear traffic, clear travels. Well, how we're gonna figure that out? It's gonna be 1.75 times 40. So then I have to figure that out. 1.75 times 40. So he's going 70 miles an hour in the clear traffic. Okay, that seems reasonable. There we go.